Hello, in this session I'm going to talk about loci. Now first we need to get a good idea about how to spell this word. Loci, L-O-C-I. Now actually loci is the plural. The singular of loci is locus. Now you must be careful not to think of this locus as the locus with a T. The locus with a T, as in locust, is the insect. Right? In mathematics, the locus does not have a T, it's just L-O-C-U-S. So that's the singular, and the plural form is loci. So let's talk about what the locus is. A locus is a point. A locus is a set of points that follows a certain rule. Just as a simple example, let me write this down. Think about a set of points at 2 centimeters from P. The P is a point here. Alright? So we have a point P, and we want to think about this set of points. Alright, a certain set of points. Now, all of these points must be at a distance of 2 centimeters from P. So if you look at this point P and think about what are the possible points that are 2 cm from P, there are many possibilities. If you take a ruler and measure out a distance of 2 centimeters, say that way, you could find a point there, which is 2 centimeters. Or it can be a point in a different direction, which is also 2 centimeters from P. It can be there. It can be in any direction, as long as it is 2 centimeters from P. It is part of this set of points. Alright, now if I keep trying out many different points that are always at 2 centimeters from P, you can imagine what I might get. A circle. And that's indeed what a circle is. On a circle of radius 2 centimeters, each point on the circle will always be at the same 2 cm from P, and P would be the center. So what we have here is, we have just found that if I have a set of points that makes up a circle, and if the center of the circle is P and the radius is 2 centimeters, then this circle is actually a set of points at 2 centimeters from P. So in that sense, this is a rule. Alright, the rule is that we want a set of points at 2 cm from P, and the answer for this set of points is the circle. So we call this circle a locus. Alright? The locus refers to the set of points, alright, which follows a certain rule. And in this example, this is the rule. The rule is that all the points must be 2 cm from P. So we have a simple example here. So in other words, this set of points actually traces out a curve. And usually, quite often, in mathematics, we have to draw this locus, and we have to draw it accurately. And the way to do that is to use the method that we learned in construction. So let me clean this circle away. Alright, now if we have this problem where we are given that the locus is a set of points at 2 centimeters from P, and we need to draw this locus, well, first we have to understand that it is a circle, and once we know that it's a circle, we can draw it using a compass. So this is my compass. It's very simple. It's just a chalk which is tied to a piece of rope, a string. Of course, you have your good compass with a sharp point in place of my hand, and a pencil in place of my chalk that you can draw nicely on a piece of paper. But I'll use this piece of rope and chalk. So what you would do is, with your compass, you would open up your compass until the distance between the needle and your pencil is 2 centimeters. You can measure that on your ruler. Then put the sharp point on P, and using the pencil, draw the circle. Let me try to do that. There. Not a very good circle, but you get the idea. That's my locus, a set of points that is 2 centimeters from P. Let's move on to another example. Now suppose now that we look at another rule, a different rule. Now the rule is a set of points that are equidistant. Points P and Q. So in this case, we are given 2 points, point P and a point Q, and we want to find a set of points that are equidistant from P and Q. Equidistant means same distance. Now let's try and think of some examples. That's always a good way to start, to figure out what what this locus, what this set of points should look like. Like I said just now, this set of points will often correspond to a certain shape. It can be a circle that we have seen, or it can be some other curves or shape. So we have to start by understanding what this shape might look like. Now in this case, how can I find some examples of points that are at the same distance from P and Q? Well, the simplest one would be the center, right? So I put a dot there. Alright, a dot at the center would clearly be at the same distance from P and Q, so that we have one point. Let's think of another example. Now, I'm just going to put my finger there. Now if I look at that point can't be at the same distance from P and Q. It's clearly closer to P and further from Q. So it has to be somewhere there. Right? So a point around there would be roughly at the same distance from P and Q. Or it can be on the other side, same distance from P and Q. Or it can be closer, roughly there or there. Now you're beginning to see a pattern. They probably form a line. And indeed, they do. In fact, this line, right, is actually the perpendicular bisector of the line PQ. Now we've learned that in construction. If you draw a line joining PQ and think of a line that cuts PQ into half at a right angle, then any point on that line must be at the same distance from P and Q, because we can, if we draw a triangle to that point, this distance must be equal. Alright, because only an isosceles triangle will produce a perpendicular line to its base that cuts the base into two equal halves. So once we have this understanding, we now know that the set of points that are equidistant from points P and Q is simply the perpendicular bisector of the line PQ, meaning a perpendicular line that cuts PQ into half. And we know how to construct that. Right. So clean off all the rough working. Now to construct the perpendicular bisector that goes through PQ, and use a compass. Now I'm going to adjust the distance of my compass until it's maybe roughly close to PQ. Doesn't have to be equal. So with that distance, I'm going to put the needle at one point, at point P. Alright, I'll draw an arc roughly where I think the line will pass through. Alright, one arc on each side of PQ. Then I go to Q, put my needle at Q, keeping the same distance. That's very important. and draw two arcs that cross the previous two arcs. Right, and now we are ready to draw a line. We need a ruler or a straight edge. So put this along the 2 points from the arc. Draw straight lines through them, and then we have our locus. It's this straight line that cuts PQ into half. So this is our locus for this rule that the set of points are equidistant from P and Q, and we can use construction to find the answer. Let's look at another example. Right. Now this time we want to find a set of points that are equidistant from two straight lines at an angle. Right. Two straight lines at an angle. So let me draw two straight lines at an angle. It's one straight line. Another straight line. So we have two straight lines that are at an angle, and we want to find a set of points that are equidistant from both lines. Now what does that mean? Equidistant from a line. Now let me just put a point there as an example. Now the distance of a point from a line is always the perpendicular distance. Meaning, if I want to know the distance from that point to this line, I have to ask, do I measure the distance from that point to that point on the line? Or do I do it from this point to that? It's always a bit ambiguous, but we always think of distance of a point from a line as the shortest distance, and that means that we think of a perpendicular distance. Alright, so when we say distance from a point to a line, we always refer to the distance that we get if we draw a straight line from the point to the line that is at right angles. In the same way, the distance of this point from the other line is given by this perpendicular from the point to the line. So when we say equidistance from the two lines, it means that these two distances must be equal. So that's the kind of thing that we want. Now that we understand the meaning of distance of a point from a line, we can roughly see that, or we can roughly think of a few other points that that are equidistant from the two lines. So it might be a point there, same roughly in between the two lines, same distance from the two lines, or point there. Alright, that has to be the same distance from the two lines, or it can be there or there. And you can already see that it is probably a straight line that cuts this angle. And in fact, it is the angular bisector. Alright, this straight line will cut the angle into two equal halves. And we can understand why it will cut this angle into two equal halves, because since each point on the line has the same distance from either of the straight lines, it must be each side of this locus must look the same. Okay, so that's why this angle between the center line and each side must be the same. And we know how to draw an angular bisector using construction. So let's do that. Alright. Now we need our compass again. So open up your compass to some distance, maybe roughly half the length of each line. Put the sharp point at the angle and draw two arcs, one crossing each line. Then, taking the sharp point of your compass and putting it on each of these points where the arc crosses the straight line. I'll start with that point, needle there, and draw an arc roughly where I think the straight line will go through. Then go to the other point, the other arc. Be careful to keep the same distance of your compass. Put the sharp point there, draw another arc. So now we have a point there. All we need to do now is to take out our straight edge and draw a line from the corner of the angle to the new point over there. Okay. Here's what we do from corner to this point. There. So that's our angular bisector, and you can roughly see that each point on this line will be at the same distance from these two lines. Now let's look at a slightly more difficult example. Suppose I have a straight line let me draw it here. Suppose I have 2 points A and B. Alright, the two fixed points. Now, suppose I have a third point P. Let me draw a line joining P to A and P to B. Right. Now we are going to make a rule for the point P. I'm going to talk about the set of points P. Alright, so we think of P, we think that P can be at different positions. So I want a set of point P's so that the angle APB is always equal to 90 degrees. That's always equal to 90 degrees. Now that's actually quite tricky. Can you think of another point that gives a 90-degree angle like that? Or maybe you can put P at the bottom, just flip this angle to the bottom and that's another point. But what other points can we have? It's actually not very obvious until we think, until we remember what we have learned in geometry for the circle. Now let's refresh our memory. If I have a circle, then when I draw the diameter, okay, suppose that's the diameter, and I draw an angle at the circumference, right, with the two lines, two sides of the angle going to the diameter. Right, in other words, the angle subtended by the diameter at the circumference. Now we have learned that this angle must always be 90 degrees. As long as this is the diameter and as long as the angle is at the circumference, it does not matter where it is. So for example, if I move that point to there, the angle would still be 90 degrees. And it's the same if I move the point to anywhere on the circumference. So that's a special property of angles in a circle. Alright. Now if you compare this picture with that one, let me make it more obvious by calling this A, B and P. So you see that from this property of the circle, that if P is any point on the circumference, then the angle must be 90 degrees. So now we know what the locus look like. Set of points P so that the angle APB is equal to 90 degrees is simply this circle. Alright? It's simply the circle where that goes through A and B and has AB equal to its diameter. So how can I construct this? It's a little tricky. Now if I want to construct this circle, I must first find the center. How can I find the center? Well, let me start by drawing a straight line through AB. Straight line. If I want to find the center, it's the same as finding the midpoint of AB. I can do that by constructing the perpendicular bisector, because that would cut AB into half. Let's do that. Start with the compass, like that. Adjust it until it's roughly equal to AB. Draw two arcs, one up there, one down there. Go here, draw another arc, one up there, one down there. Take out my straight edge, put it by the new points formed by the arcs. Draw a straight line through them. And this is the perpendicular bisector that cuts AB into two equal halves. So if AB is cut into two equal halves, this point must be the center of the circle. Once we have the center of the circle, we can draw the circle. Take out our compass again. Now we want to put the needle of the compass at the center, of course, and we have to adjust the length of the compass, or the width of the compass, to the radius. So if I put my needle at O, I would adjust the compass until the pencil is at B. There. And now I can draw my circle. Okay. Going to the other side. Something like that. We got our circle. So this is our locus. It's a locus of the points P, so that angle APB, so that this angle is always 90 degrees. So if you move P around to any point on this circle, the angle made by APB would always be 90 degrees because of this property of angles in a circle. Right, we'll stop here for this session. Thank you.